Imagine staring into the depths of a cosmic abyss, where an object so powerful it resembles the Eye of Sauron has been hurling record-breaking particles toward Earth. Sounds like science fiction, right? But this is real, and it's happening right now. A distant supermassive black hole, known as PKS 1424+240, has been sending us some of the most energetic neutrinos ever detected, and scientists have finally uncovered the secrets behind this phenomenon. PKS 1424+240 is no ordinary black hole. It's what astronomers call a blazar, a type of active galactic nucleus, powered by a supermassive black hole that spews out jets of plasma at incredible speeds. This particular blazar has puzzled researchers for years because, despite its relatively slow-moving jet, at least in appearance, it emits some of the most energetic gamma rays ever observed and is the brightest source of neutrinos among all known blazars. Now, thanks to 15 years of meticulous observations using the Very Long Baseline Array, VLBA, we're starting to understand why. Here's the kicker. It turns out we're looking directly down the barrel of this cosmic gun. The jet from PKS 1424+240 is aligned so precisely with our line of sight that it's only 0.6 degrees off. Imagine standing at one end of a football field and squinting through a straw. This is how finely tuned this alignment is. And this near-perfect alignment has profound implications. When we reconstructed the image, it looked absolutely stunning, said Yuri Kovalev, lead author of the study and principal investigator of the ERC-funded MUSES project at the Max Planck Institute for Radio Astronomy, MPIFR. We've never seen anything quite like it. A near-perfect toroidal magnetic field surrounding a jet pointing straight at us. But here's where things get interesting. This alignment creates what's known as a relativistic boosting effect. Essentially, the light and energy emitted by the jet appear much brighter to us than they actually are, because the jet is pointed almost directly at Earth. According to Jack Livingston, a co-author of the study, this effect can amplify the brightness by a factor of 30 or more. At the same time, the jet seems to move slowly across the sky due to projection effects, an optical illusion caused by our perspective. Now, let's break down the science behind the neutrinos themselves. Neutrinos are incredibly lightweight particles with no electric charge, making them nearly invisible to detection. They're produced during nuclear reactions, such as those occurring in the sun or during radioactive decay. In space, however, these elusive particles often originate in far more violent environments. For example, when high-speed protons accelerated by the magnetic fields in a blazar's jet collide with photons, particles of light, they create other particles called pions. These pions then decay, releasing neutrinos in the process. What makes this discovery so groundbreaking is that it confirms something many scientists suspected but hadn't yet proven. Supermassive black holes and active galactic nuclei aren't just accelerating electrons. They're also propelling protons to velocities close to the speed of light. This dual acceleration mechanism explains the production of both gamma rays and neutrinos, shedding new light on the inner workings of these cosmic powerhouses. Solving this puzzle confirms that active galactic nuclei with supermassive black holes are not only powerful accelerators of electrons, but also of protons, the origin of the observed high-energy neutrinos, concluded Kovalev. So, what does this mean for us? Well, beyond expanding our understanding of the universe, detecting these neutrinos provides a unique window into regions of space that are otherwise impossible to observe. Special detectors like IceCube in Antarctica have already captured some of these ghostly particles, proving that even the most intangible aspects of the cosmos leave traces we can study. And this is the part most people miss. While the findings are fascinating, they also raise questions about the broader role of blazars in shaping the universe? Are there more objects like PKS 1424 plus 240 out there, hidden in plain sight? Could their neutrino emissions influence the evolution of galaxies over billions of years? But here's where it gets controversial. Some scientists argue that interpreting these results might require rethinking certain assumptions about how magnetic fields behave in extreme environments. If the magnetic field around this blazar is indeed helical or donut-shaped, as the data suggests, could similar structures exist elsewhere in the universe? And if so, what does that tell us about the fundamental forces at play? As you ponder these questions, consider this. Does the idea of peering into the heart of a black hole excite you or terrify you? Do you think humanity will ever fully unravel the mysteries of the universe? Or are some enigmas destined to remain unsolved? Share your thoughts in the comments below. We'd love to hear your take.